Good morning, children. Today we are going to learn about similarity. In the previous class, we learned about congruency. What is the rule of congruency? Corresponding angles must be equal, corresponding sides must be equal. That means almost both the figures must be of the same size. Like the image, one should be the image of the other. But we are going to discuss about which particular figures we call them as similar. The condition here is that shape must be same. Exactly the cutouts, right? Whatever the shape that you are giving should match with each other. It can be small or big. So when you take two pictures, shapes must be equal. Shapes must be same. I'm sorry. Shapes must be same. But the picture can be small or big when compared to the given picture. And that means which says that size may be different or size is different rather and shapes are same. Such figures we call them as similar figures. Such figures we call them as similar figures. They look alike but they are not of same size. They look alike but they are not of same size. Suppose if we take triangles, like I have here three triangles. So the shapes of the triangles are same. Why? Because in case of triangles, the corresponding angles are same. Because we already discussed that shape is decided by the angle. Shape is decided by the angle. Here corresponding angles are equal. But see, the sides are not equal. This is very, very small triangle. Then this is of medium size. This is of bigger size. See, sizes are different, but shapes are same. Here if you see, this is a parallelogram. Here the angles the corresponding angles are equal, but the sizes are different. The sizes, that means the corresponding sides are different. So then, is there a relationship between the corresponding sides? Absolutely. Sides are proportional to each other, where angles are congruent. Angles are congruent. That means corresponding angles must be equal, but sides are proportional. What is meant by proportional? Ratio of the corresponding sides is going to be constant. Right? Ratio of the corresponding sides is going to be constant. That means suppose if I take, let me take a rectangle here whose breadth is 1 and length is 2. If I draw a rectangle with making breadth 2, making breadth 2 means how many times you have increased the size of the breadth? 2 times. Then absolutely length should also be increased by 2 times. That means breadth by breadth, length by length, both should give same result. See here length is 2. So it is a must that if you want to draw a similar rectangle, if the breadth is increased by 2 times, then length should also be increased by 2 times. That means ratio of the breadths is equal to ratio of lengths. Okay, ratio of breadth is equal to, see now, see what is the ratio of the breadths? 1 by 2, smaller by bigger, which is equal to, now this is 2 by 4, ratio of lengths. So when you simplify it, it is again 1 by 2, isn't it? So that means that is the meaning of proportional. That is the meaning of being proportional. Sides are proportional. So that is what, in simple terms, ratio of corresponding sides is constant. You should get the same ratio, same constant value in case of the ratio of corresponding sides. Now let us see a particular example here. Suppose if I say that my triangle ABC is similar, this is a symbol of similarity. So you have seen the congruency. What is that? There is an equal to below the similarity in case of congruency. This is similarity. Right. So this is similar to this. That means triangle ABC is similar to PQR. See, corresponding angles are equal. Angle C is equal to angle R. Angle A is equal to angle P. Angle B is equal to angle Q. Then only we say that triangle ABC is similar to triangle PQR. If not, we won't say. If it is given, it means corresponding angles are equal. If it is not given to be like this, and if corresponding angles are given to be equal, then obviously it follows that the two triangles are similar. Okay. And when they are similar, what is the other rule that we have? The ratio of the corresponding sides should be same. See, that means suppose if I take AC, what is the corresponding side of AC? PR. So AC by PR, if it is some constant K, if AC by PR is some constant K, then AB by, this is AB, which is base, is here the base is PQ. So AB by PQ should also give the same value K. And similarly, other side, if you take BC by QR or CB by RQ, corresponding sides, these two are corresponding sides, then the ratio should be the same. That means then only we say that these are proportional, right? So that is AC by PR, corresponding sides, ratio of corresponding sides is equal, right? So this is what the similarity is. Understanding similarity thoroughly means shape should be same, size will not be same. If size is also same, it is congruent. We are not going to say that they are similar, they are congruent. So here similarity is that how does similarity differ from congruency? Congruent means both shape and size must be same. Similar means only shape is same but size is different. Okay. So children, pause the video, take the screenshot, copy the notes. Now let us see the next part. Congruent versus similar. How are they different? See, if I am given a rectangle, if I fold it exactly at the center, so that one matches with the other one, okay, one half matches with the other half, then these two halves are congruent. These two halves are congruent. This is same size as that of this, because I am folding it exactly at the center. So this comes, and as if you flip this one, this comes and matches with the other one. So these two halves are congruent. These two halves are congruent. Okay. When it comes to similar, take the same rectangle, draw a line exactly at the midway, dividing the rectangle into two halves. So one half is similar to this one, the complete rectangle. Condition is that this must be parallel to this. This line what you are drawing should be parallel to this one. If that is satisfied, whatever the smallest part, and it is not necessarily at the midway, you can also draw it here. See, if I draw the line here, so this is the one which is similar to this, and this is the one which is similar to this. So like that we will be getting the similarity. What is that? Shape is same but sizes are different. Okay children, so this is how we express like congruency and similarity. Now let us see another example. If I take a triangle, I am drawing a line parallel to the height of the triangle here. Here also I am drawing a line parallel to the height of the triangle. So what is happening here? You got a smaller triangle similar to the shape of the bigger one. Here I am getting a smaller triangle similar to the shape of the bigger one. What is the bigger one? Triangle ABC is the bigger one. And AQP is smaller triangle. But here see the same angle here. Since this is parallel to this is right angle, this is right angle, and this is similar to this one. This is similar to this one. Or same as, right, congruent. So here angles are congruent. Angles are congruent. So therefore sides are proportional obviously. Hence it is this smaller triangle is similar to the bigger one. What is the condition here? Here whatever you are drawing in a particular triangle, it should be parallel to one of the sides. I may draw it here also parallel to this. If I draw a triangle like this, if I draw a line like this, yes, this triangle at that time, this triangle is similar to the bigger triangle. So let me name it as MN. So now triangle MNC is similar to, in a similar order you have to take. You can't take it to be BAC. Similar order, M, N, C, corresponding sides, A, B, C. So it is similar to triangle ABC. So what is the condition? This line should be parallel to this. This line should be parallel to this. Suppose if I draw a line parallel to this also like this. So what the triangle here I am getting is similar to the bigger triangle. Right, now coming to the congruency. See, here these two can't be congruent, isn't it? These two. So this is a trapezium, this is a triangle. So it is not congruent. Now let us see another example, the example of a circle. So take a circle. With the same center, draw a circle inside the other circle. So you have two circles, C1 and C2. Shapes are same dear, because as well as the center is also the same. But here sizes are different. Therefore, it is not congruent. They are not congruent. But here, so see, shape is same circle again. But sizes are different. Hence, these are similar. Now, if I speak about congruency here, I can fold my paper here exactly like along the diameter of the circle. Then when this is flipped like this, automatically this is congruent to this, or this is congruent to this. Right? But a circle inside another circle cannot be congruent to the inner circle. But here, a circle which is an inner circle can be similar with the outer circle. Is that clear, children? Did you understand the meaning of congruency and similarity? Remember only one thing. Use your common sense always. Shape should be same, size should not be same. That is similar. Shape and size both are same, then only they are congruent. Whichever shapes. Here though we are taking geometrical regular shaped figures. It can be a tree, it can be a leaf, it can be anything, any kind of drawing. So always see that the shapes are same and the sizes are same means they are congruent. Shapes are same but sizes are different. Rather we can say proportional, then they are similar. Okay, so pause the video for a moment, take the screenshot. The first case of rectangle, the second case being triangle, and the third example being circle. So the next one is how to draw a similar figure of a given figure. Can be an enlarged figure or can be a smaller figure, but it should be quite similar with the original one. So in mathematics we have a process called dilation. We have a process called dilation. Usually this dilation we will be doing it on graph paper. It will be much easier for us to understand dilation on a graph paper. But here I am showing you how to draw dilation first. Then afterwards on the graph paper let us see how to measure and draw it. Okay. So now see, if I am given this one, rectangle ABCD. Okay. In a plane, maybe in XY plane. Right? In XY plane, what am I given? ABCD rectangle is given. I want to have an enlarged picture of it. So, just from the origin, let me draw a line which passes through vertex A, dotted line. Okay? From the origin, let me draw a line or a dotted line which passes through vertex A. Then another line which passes through vertex B, again from the same point, that is origin. And another line through vertex C, similarly through vertex D. So now I have got 4 lines passing through the 4 vertices of the rectangle here. Now here though I am not minding about like the size, but I am just starting my picture over here. See, suppose if I have to start another rectangle, so corresponding point, that means here A is this. Now I want to take the corresponding point here. So that point lies absolutely on the line which is drawn through the vertex A. So therefore this is A prime. Suppose if I don't want to draw it here, I can draw it here also, not an issue. So forget about this rectangle. You can draw it here also. You will get much more bigger one. You will get much more bigger one. But which point? So before we start drawing, if we want to keep the vertices, then you have to see that the vertex lies exactly, corresponding vertices lie exactly on the line which is passing through that particular vertex. So now this edge, that is the right edge. Right edge, this passes through, this is the one which lies on the same line which passes through this. And then the third vertex, then the fourth vertex on the fourth line. So this is how you have to put the points, and then if you join them, absolutely you will be getting a rectangle which is of bigger size, which is of bigger size. Now how many times we have to multiply it? Usually that depends on scale factor. What do we call that to be? Scale factor. See, that is defined as OA prime divided by OA. OA prime means the A prime is the one which is the diagram drawn by us. What is given is A. OA prime by OA is the scale factor. Let us see how this scale factor is going to help us in enlarging it. Okay, in the example provided in your textbook. See. Yes, now say this is an example for a dilation. Here the scale factor is OA prime by OA. Okay, see now, see diagonal of the square. This is a graph sheet. Okay, and now you can see that OA prime, OA. OA is a diagonal of one square, and OA prime is a diagonal of two squares. Then if this is 2x, this is going to be x. 2x by x is 2 times. So your scale factor is 2 times. Your scale factor is twice. That is 2 is the scale factor. Now to understand this scale factor, 2 in the sense, whichever figure you are going to draw now can be enlarged by 2 times or can be reduced by 2 times. Either it can be enlarged figure by 2 times, or you can also draw a diminished figure or the reduced figure by 2 times. See, in this diagram you can see that this is the blue color one is the one which is having unit, that means one particular square. That means suppose if we take one square as 1 centimeter here, so 1 centimeter of width and 2 centimeters of length. So what is the scale factor we took? 2. Absolutely, when you extend these dotted lines, and now when you start from here, you can see that it is of 2. So 1 centimeter here width, here it is 2 centimeters. Here the length is 2 centimeters. Here how much? 1, 2, 3, 4. 4 centimeters is the length. So how many times it is increased by? 2 times. So what is the ratio of the corresponding sides? So 1 centimeter by 2 centimeter. 2 centimeter by 4 centimeter. That means scale factor is the one which is going to decide how many times you are going to enlarge a picture. This is very important in dilation. So take the screenshot of this and take a graph sheet if you have at your home, or you can purchase in the bookstalls. Now they are open. If you don't have also, you can create your own rough graph and then draw this one. So here it is given to me scale factor to be 2. And children, pause the video here and write the notes. So now coming to the last part of the lesson, applications of similarities. So first, what are similarities? Corresponding angles are equal. So in a book, if 2 pictures are given and you can find out the unknown angle. Why? Because you can equate the corresponding angles. That is one of the application. Ratio of corresponding sides is equal. If a particular side is not known to us of a particular diagram, you can equate the ratio and you can find out the unknown value x. You know it very well, is it not? So now, well, let us see somewhat a next level of it. See, if I have taken a triangle, so I am taking triangle here and square or a rectangle as one of the examples to understand where and where similarity concepts can be used. So here I have a triangle. So this triangle is similar to this. How can we say, yes, angles are same? I didn't mention here. Let me mention. So corresponding angles are equal. Yeah, I mentioned it. And now if you observe the size, base here is 1.5. This is 3. Means 2 times. So this height is 2. This is 4 times. So this is a right angle triangle. This is a right angle triangle. Right. So 2 means 4. This is 2.5. 2 times is 5. So absolutely these two are similar. Right. Triangle ABC and triangle PQR are similar. So what is that you have to remember when you are saying corresponding vertices? You should A, P, B, Q, C, R. Those corresponding vertices you should maintain. You can't say that triangle ABC is similar to triangle RPQ. Absolutely wrong. Okay, so that is important, very, very important. It may not be now, but when you go to 10th standard, that is going to be the most important factor whenever you solve so many theorems and so many laws and so many applications based on similar triangles. And that's the most important topic in class 10. Right, now triangle ABC is similar to triangle PQR. Now our point here is, let me take the perimeter of ABC. P of ABC. Perimeter of ABC. What is that? Base, right? AB plus BC plus CA, is it not? So what is AB here? 1.5. What is BC? 2. Plus what is CA? 2.5. So what did I get? 1.5 plus 2 is 3.5. 3.5 plus 2, 5.5 plus 5.5. That is 6. 6 centimeters. Now let us see the perimeter of PQR. Triangle ABC, triangle PQR. So what is triangle PQR perimeter? Sum of the sides is not 3 plus 4 plus 5, which is 7 plus 5, 12. Now what is the ratio of these two? 1 by 2, is it not? It is 1 by 2. That means ratio of perimeters is equal to ratio of corresponding sides. Is it not? Fantastic relationship. So if the question is asked, suppose two triangles are similar. If you are asked to find out ratio of perimeters, no need to find perimeter and do this. You can use this statement directly. Ratio of perimeters is equal to ratio of corresponding sides. Find the ratio of the corresponding sides, you equate it to perimeter. Children, please remember this point. Don't blindly go by this method, saying that this is how we are proving it. I gave you an example to understand it. Okay. Now areas, we'll say. Area of ABC. Half, base is 1.5 into what is the height? 2. Right. So I can write it as half. In place of 1.5, I'll write 3 by 2. In place of 2, I'll write 4 by 2 to make you people understand easily. So that is half of 3 into 4 by 2 twos are 4. Right. So now area of PQR. What is that? Half into 3 into 4. So that is half 3 into 4. Now when you find the ratio of these two, what is that? 1 by 4 times. You are getting it to be 1 by 4 times. This and this will get cancelled. So thus you can conclude that ratio of areas is equal to ratio of squares of sides. Squares of sides. That means if you have ratio of sides, square of, better you write it as square of ratio of sides. Square of ratio of sides. What is the ratio of sides you got? 1 by 2. Here what is that area you are getting? 1 by 4 means 1 by 2 square. 1 by 2 square is 1 by 4. Okay? Right. Similarly, you can also see here. Perimeter is the same. here 2 plus 1 plus 2 plus 1 because opposite sides are equal. And that means the same conclusion you are going to get it here. So now here, what is the area formula? 2 into 1, is it not? So it is 2 into 4. So it is 2, it is 4 2s are 8. So now let us see. Ratio of perimeters directly I am finding here. Let us see how it is going to be. So 2, 2, 1, 4. Right. 2 sum of the sides. So 4 plus 2, 6 by 4 plus 2, 6, 6 plus 6, 12. So what is this? 1 by 2. That means ratio of perimeters is equal to ratio of sides. Corresponding sides. Always I am writing only here sides. It means corresponding sides. Okay. Now ratio of areas, let us see. What is the formula for area of a rectangle? Right? Length into breadth, is it not? Length into breadth. 2 into 1 by 4 into 2. So it is 2 by 8. So what is 2 by 8 is equal to 1 by 4. Is it not? 2 1s are 2, 2 4s are 8. 1 by 4. So now the same thing now. Therefore ratio of areas is equal to square of ratio of sides. Can also be said as square of ratio of perimeters, because we are getting both to be the same. Very, very important conclusions, children. Right? So in detail you take another example. I took it as like twice. You take something like 3 times. Draw the diagrams in both the cases and prove in both the cases whether these statements are correct or not. This is your homework along with your exercise. So this is very, very important part. So now you have taken the screenshot of this already. Now coming to the part of applications of similarities. Right, take a screenshot and copy that, children. See you in the next class. Your homework, you have to finish the first exercise from the chapter. As well as I said, here I have taken the ratio to be 2. That means 2 times increase. Here also 2 times increase. In the example, you take 3 times increase and prove me that the perimeters ratio and sides ratio is same. And ratio of areas is square of the ratio of the sides. Okay. So take the screenshot and copy the notes.